All right, this is the video for the Algebra 1 with Lab for the word problems test. I'm actually going to skip questions 1 and 2 because we really went over them in class. And I'm going to start with question 3. All right, so here's question 3. The larger of two numbers is 9 more than twice the smaller. That needs to be translated. You draw your 3 columns. Your first column, remember, is for the translations and your setup. So let's see, the larger of two numbers is 9 more than twice the smaller. The item that appears at the end of that sentence is almost always your x. So x is going to be the smaller number. And then we now need to translate the rest of it. The larger of the two numbers is 9 more than twice the smaller. So 9 more than, I'm going to add 9 to twice the smaller, or twice x, or 2 times x, and that is the larger. So now we have it all translated out. The sum of the two numbers and 18 is 162. So the is, let me not circle these just yet. The is your equal sign. So here's your equal sign. The sum of the two numbers and 18 is your sum. The sum of the two numbers and 18 is equal to 162. So I'm going to take the sum of these two numbers. My x is my smaller, plus my 2x plus 9 is the larger, plus the 18 that they had in the word problem, the 18 equals 162. And now I can solve, so I just have to clean this up. X plus 2x is 3x. 9 plus 18 is 27. That equals 162. Subtract 27 on both sides. And so we get 3x equals 135. Divide by 3. X is 45. And now they're asking me to find, the last column is reserved for what we're being asked to do. We want to find the smaller number. Well, if I look back at the setup column, x was the smaller number, so the smaller number is just 45. It's just the x value. That equals x, which equals 45. There's my answer. All right, number 4. Mrs. Zoll is decorating her classroom for Halloween. She wants to put a Halloween border around the edge of the rectangular floor in her room. Boom, there's my setup. I'm going to be drawing a rectangular floor or a rectangle. Here we are. So Ms. Zoll wants to put a border up on that. Now, the width of Mrs. Zoll's classroom is 5 less than twice the length of the room. Stop right there. I have a translation piece right here. The width is 5 less than twice the length of the room. The length is coming at the end of that piece. That's your x. That's your length. Then your width is 5 less than twice the length. So 5 less than, I subtract 5 at the end. This is where people mess up. 5 less than twice the length would be 2x minus 5. Remember to switch the order here with less than. 5 less than comes at the end. You're subtracting at the end. 2x goes first. 2x minus 5 is your width. So we have 2x minus 5 is the width. And x is the length. Put those things in on my picture. Notice the diagram is really helpful. You'll see why in a second. And Mrs. Zoll, so I'm reading from here, and Mrs. Zoll figured out that she will need 80 feet of border to cover the edge of the floor. So she's putting up her Halloween border. Okay? She needs 80 feet to cover the edge of the floor. I need to add up all 4 sides. All 4 sides need to be accounted for. So if I start here, I have my x plus my 2x minus 5 plus my x plus my 2x minus 5. Let me just move this line a little bit. Plus 2x minus 5, and that all adds up to 80. Okay, now we have an equation. So let's solve the equation. That always gives us something. X plus 2x plus x plus 2x. That is 6x. Negative 5 minus 5 is negative 10. That equals 80. Add the 10 over, and we get 6x equals 90. Divide by 6, x is 15. 15 is the length. The question's asking me, so again, that last column is reserved, what is the area of the floor? Well, area of a rectangle is length times width. Well, we just figured out that 15 is the length. I have to multiply by the width. Well, the width was 2x minus 5. But if x is 15, I now can figure out the width. 2 times 15 minus 5. 2 times 15 is 30. 30 minus 5 is 25. So there's my width, 15 times 25. And now my area, I'll multiply. 15 times 25 is 375. And 15 is being measured in feet. 25 is being measured in feet. When we multiply feet times feet, we get square feet, or feet squared. Think about the floor in our classroom. It's made up of squares. Area is the space being filled up. Final answer is 375 square feet. Next up, in an isosceles triangle. Boom, guess what? I'm drawing an isosceles triangle. Here it is. Isosceles has 2 equal sides and 1 unequal side. The 2 equal sides are called the legs. One of the legs is 4 times the base decreased by 8. So one of the legs is 4 times the base decreased by 8. 4 times the base is 4 times x decreased by 8. I decrease this, I subtract by 8. That is going to be one of the legs. And the thing that comes at the end, they're referring to the base, that's your x. Some people get confused with the decreased by. Decreased by gets translated directly. So for example, if you had a 95 and I decreased your grade by 5 points, that would be 95 minus 5. No switching there. So now we have my legs are 4x minus 8 apiece. The legs are equal and the base is x. Now it says if the perimeter is 443. The perimeter means I'm going to add up all of the sides. All of them. Some people like to only add up a couple. I need to add up all 3 sides. So I'm going to have 4x minus 8 plus 4x minus 8 plus x equals 443. Let me just move my column out a bit. Equals 443. And I solve this equation. 4x plus x is 9x. Negative 8 minus 8 is negative 16 equals 443. Add 16 to both sides. We get 9x equals 459. Divided by 9. Divided by 9. X is equal to 51. We have to read the question. The question said I want to find the length of one of the legs. X was not the leg. X was the base. So I have to take the leg expression and plug in my x value. So I have 4 times 51 minus 8. 4 times 51 is 204. 204 minus 8 is 196, which is how much one of the legs is. All right, next up. Find 4 consecutive integers whose sum is 62. Once I see 4 consecutive integers, this is great for you because you know the setup. My first consecutive integer, actually I want to make this a little less wide. My first consecutive integer is x, and from there, first consecutive integer is x. X plus 1 is the next one. X plus 2 would be the third one, and I need 4 of them. So x plus 3 would be the fourth consecutive integer. Each time I'm going up by 1, and the sum of these things has to be 62. So x plus 1 plus x plus 2 plus x plus 3 equals 62. X plus x plus x plus x is 4x. 1 plus 2 plus 3 is 6 equals 62. Minus 6 on both sides. 4x equals 56. Divide by 4. X is 14. They want me to find all 4 consecutive integers. So I start off with my x. My x is 14. 14 plus 1 is 15. 14 plus 2 is 16. 14 plus 3 is 17. And those are 4 consecutive integers. I could check these by adding them up and checking that they add up to 62. And in fact, they do if you add up these 4 numbers. Next up, find the largest of 3 consecutive even integers. Boom, 3 consecutive even integers. I know my setup. That's what's so nice. X is the first consecutive even integer. X plus 2 is the second consecutive even integer. X plus 4 is the third consecutive even integer. There's my setup. Such that the sum of the first 2, so I'm actually going to read this literally. The sum of the first 2 results in, that's my equal sign, the third increase by 34. So sum of the first 2, I will write it out in words, equals the third increased by, add 34. So some of you might be helped by kind of writing out in kind of like a words algebra hybrid here. Kind of you have some couple of words, a little algebra, and then fill it in. The sum of the first two. Well, my first one is x. My second one is x plus 2. X plus 2. There's my sum. Equals the third. The third is called x plus 4. And I have to increase that by 34. And now we have an equation. X plus x is 2x, so I have 2x plus 2 equals x plus 4 plus 34 is 38. Subtract the x on both sides. We have x plus 2 equals 38. Subtract 2 on both sides. We get x is 36. So if x is 36, I want the largest. I want to find, this is your find column or your question column, find the largest. I want to find the largest one. So if x is 36, that's not the largest. X plus 2 would be 38. X plus 4 would be 40. So the largest equals 40. All right, next question. The ages of Elizabeth and Kristen are consecutive odd integers. Stop. We have consecutive odd integers. That's our initial setup. Now it's an age problem. I'm going to make my column a little wider because the ages of Elizabeth and Kristen are talking about today or now. So today, okay, I have Elizabeth and Kristen, consecutive odd integers. I'll say Elizabeth is going to be x, and Kristen, I'm abbreviating, is x plus 2. Think about if Elizabeth is an odd age. For example, 5. 5 plus 2 is 7. That's going to get me the next odd. Even though 2 is even, that's still going to get me the next odd. Now, 20 years ago, something happened. 20 years ago, we need to stop. And we need to represent ages 20 years ago. So once you get to those words, you stop. And you're going to say, okay, Elizabeth was X today. What was she 20 years ago? Well, she would be X minus 20. So for example, if Elizabeth was 10, oh, sorry, I can't use 10. If Elizabeth was 30, her age 20 years ago would be 30 minus 10, which is 30 minus 20, which is 10. Same thing here. I'm going to take Kristen, X plus 2, and subtract 20. So if you're looking at this color-coded, I'll color-code this. I'm taking my old ages, which are in red, whatever they are. I'm taking the old ages and doing the same thing to both. I'm subtracting 20. I'm subtracting 20. Okay? And this becomes X plus 2 minus 20 becomes X minus 18 for a simplified version. So here are my 20 years ago simplified versions. And now I'm going to work with them because this sentence is talking about 20 years ago. So Kristen's age was 3 years less than twice Elizabeth's age. Well, let's see. I'm going to look for the equal sign. Kristen's age was, there's my equal sign, 3 years less than twice Elizabeth's age. So Kristen's age was 3 years less, so that's subtraction of 3, twice Elizabeth's age. Okay? Kristen's age, here I am, Kristen's age was 3 years less than twice Elizabeth's age. And I'm doing this all 20 years ago. So now I'm going to dump in my 20-year ago ages. Kristen's age 20 years ago, if I look at my key, Kristen's age 20 years ago was X minus 18. Equals 2 times, what was Elizabeth's age 20 years ago? Elizabeth was X minus 20. And then a minus 3. So now I have my equation. So I have X minus 18 equals 2x minus 40 minus 3. So I have x minus 18 equals 2x minus 43. Subtract x from both sides. We get negative 18 equals x minus 43. I have to move this thing, this up here. We'll add 43 to both sides. And so x is 25. Let's not forget what x represents. X represents Elizabeth's age today. We have to answer the question. So they wanted to answer, how old is Kristen now? Well, x is Elizabeth's age. I don't want to give Elizabeth's age. The question is asking about Kristen. Kristen today is x plus 2. So Kristen is 25 plus 2, which is 27. So I didn't have an answer column here like I usually do. But the answer, the final answer to the question is Kristen's age, which is 25 plus 2, which is 27. So Kristen is 27 now. All right, next problem. Another age problem. So I'm going to make a big Y column here. 10 years ago. Boom, I'm talking about 10 years ago now. 10 years ago, Mark was 4 times as old as Paul. Well, guess what? I don't even know anything about today till I keep reading. So I want to make this column 10 years ago. And as long as I know that I'm talking about 10 years ago, I'm fine with this. Mark was 4 times as old as Paul. If I call Paul's age X, this is 10 years ago again. Paul's age is X. Mark was 4 times as old as Paul. So that's 4X. Now, the next sentence starts talking about today. So today, blah, 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 blah. Well, guess what? If Paul was X 10 years ago, today we have to think about what he's going to become. So imagine Paul was 6. He was 6. This is 10 years ago. So today, he's older, not younger. So today, we're going to add 10, and he'll be 16. I'm using that as an example. So we're going to take X, we're going to take the green X, and add 10 to get his age today. Okay, same thing. We're going to take Mark's age, his 4X, and if we're going 10 years, we're going to add 10. Same idea. Okay, I'm going to erase this because it was just an example. I'll show you how to do that. Now, today, we have expressions. It says Mark is twice as old as Paul. So when we write the equation, we're going to use today's stuff. So today, Mark is twice as old as Paul. Mark is equal sign twice as old as Paul. Mark is twice as old as Paul. There we go. So today, what's Mark's age today? Well, Mark was 4X plus 10 today. Equals 2 times Paul today was X plus 10 in parentheses. The X plus 10 is married, they're in parentheses. Now we got to solve. 4X plus 10 equals 2X plus 20. Subtract 2X from both sides. We get 2X plus 10 equals 20. Subtract 10 from both sides. I get 2X equals 10 divided by 2. X was 5. X was 5. Now we have to answer the question, which is a little tricky. How old will Mark be 20 years from now? Whoa. So X is 5. Let's see what X is. If I go back to my key, X was Paul's age, but 10 years ago. So we can get Mark's age. We can get any age we want, as long as we know what X is. We want Mark's age 20 years from now. Well, that begs the question, well, how old is Mark now? Now, Mark is 4X plus 10. If we look in our today column or our now column, Mark is 4X plus 10. So Mark is 4 times 5, our X value, plus 10. 4 times 5 is 20, plus 10 is 30. That's how old he is now. I want how old he is 20 years from now. So guess what? He's going to get older. If we go 20 years from now, he's going to get older. 30 plus 20 is 50. So Mark will be 50 20 years from now. That's a tougher question. All right, number 10. To raise money for more money for the freshman class, Rachel, Laura, and Dylan sold sweatshirts. Okay, so set up column. Here we are. Dylan sold 4 times as many sweatshirts as Rachel. And I want to stop because that's a fact. Rachel's at the end of the sentence. She's my X. X is going to be Rachel's sweatshirts. Okay, there it is. Now, Dylan sold 4 times as many. So Dylan will be 4X. And Laura sold 5 less than 3 times the number of sweatshirts that Dylan did. So watch this. Laura sold 5 less, so I'm subtracting 5 at the end, 3 times the number that Dylan sold. I'll write it out in words first. That's going to be Laura. Yes, that's going to be Laura's sweatshirts. Now I wrote it out in words because what is Dylan's number of sweatshirts now? Well, it's 4X. So Dylan is 4X. I'll erase it now. Just kind of give myself a little template to fill it in. And 3 times 4x is 12x. So 12x minus 5 is really Laura's sweatshirts. So I'm actually going to erase this now that we saw where it came from and plop this in its place. So 12x minus 5 is Laura's sweatshirts. Altogether, the 3 students sold 29 sweatshirts. Altogether means I'm going to take all 3 of their expressions and add them up. X plus 4x plus 12x minus 5 equals 29. Now I have an equation. Well, let's see. I'm not even answering the question. Look what we're doing here. I'm setting up an equation. I want to be able to get x. Once I get x, I can answer the question. X plus 4x plus 12x is 17x minus 5 equals 29. Add 5 to both sides. 17x equals 34. Divide by 17. X is 2. Now let's read the question, because that's what this is reserved for. Dylan's goal is to sell 11 sweatshirts. How many more sweatshirts does Dylan need to sell? Well, let's take a look. Dylan's sweatshirts that he sold were 4x. I know x is 2. So 4 times 2 is 8. This represents the number of sweatshirts he sold already. Well, if he sold 8 and he wants it to go to 11, to figure out how many he needs, I'll subtract the 2. That'll make up the difference. So Dylan needs to sell 3 sweatshirts. Final answer, Dylan needs to sell, let me get this out of the way, 3 sweatshirts. Okay, next question, number 11. What is the smallest of 4 consecutive integers? Boom. Once I see 4 consecutive integers, I know my setup. X is my first one. Add 1 for the second. Add another 1 for the third. Add another 1 for the fourth. Now here's where it gets tricky. If 19 less than, so I'm going to try to write this out in words. 19 less than the sum of the second and the third is equal to the fourth. Here's my equal sign. Whoops. Erase that. I want to write it out in words. That seems to be something that's working for people. 19 less than something. The sum of the second and the third. So sum of second and third is equal to the fourth. So there we are. 19 less than the sum of the second and the third is equal to the fourth. Well, the sum of the second and the third, sum of the second, here's the second integer, and the third, I have to add those up. X plus 1 plus x plus 2 minus 19 equals the fourth. The fourth is my x plus 3. Now I have an equation, I can solve it for x. So let's take a look. I'm going to have 2x, 1 plus 2 is 3, 3 minus 19 is negative 16, equals x plus 3. Subtract x, we get, 2x minus x is just x. X minus 16 equals 3. Add 16 to both sides, and x is 19. There's my x value. Now I want the smallest of the 4. Well, guess what? The smallest of the 4 is just going to be x, because x plus 1 is bigger than x. So the smallest of the 4 is just 19. Good. Moving on. Number 12. 2 less than twice a number is 34 less than 3 times the number. Find the number. Well, guess what? 2 less than twice a number, my x is just the number. That's a pretty easy setup column. 2 less than twice the number. So if I have, let me make this go back. 2 less than twice the number, looks like this, is my equal sign. 34 less than 3 times the number. There we are. Again, remember, less than is translated backwards as how you read it. All right, we're subtracting 2x from both sides. Negative 2 is x minus 34. Add 34 to both sides. And x is 32. And we're done, because that's the number. That was an easy one. Number 13. Here's a tough one. In 40 years, I want to read this one totally. In 40 years, Elise will be 4 times as old as she was 8 years ago. How old is Elise now? It's very easy in this question to get kind of mixed up with what the variable is. How old is Elise now? I'm going to call that x. Okay, and I'm going to make a wide setup column here. I'm going to say x is Elise's age now. So I want to write today, Elise is X. That's how old she is today. Now I'm going to read the problem again. In 40 years. Well, what happens in 40 years? Elise gets nice and old. So we're going to add, we're going to take the X, the blue, and add 40. That's her age in 40 years. Elise will be 4 times as old as she was 8 years ago. There's another time word. 8 years ago. Can I figure out what her age was 8 years ago? Well, if her age today was X, I'll take that X and subtract 8 to get her age 8 years ago. So now we have Elise was X. In 40 years, she's X plus 40. 8 years ago, she was X minus 8. Now, we have to read and try to form the equation. In 40 years, Elise will be 4 times as old as she was 8 years ago. So I want to look for the equal sign. In 40 years, Elise will be, that's my equal sign. So in 40 years, her age will be 4 times as old as she was 8 years ago. So in 40 years, so watch how this works. In 40 years, she will be 4 times as old as she was 8 years ago. Now we dump in. So in 40 years, her age was X plus 40. Equals 4 times her age 8 years ago. Her age 8 years ago was X minus 8. And now we solve. So X plus 40 equals 4X minus 32. Subtract X on both sides. 40 equals 3X minus 32. Add 32 to both sides. 40 plus 32 is 72. 72 is 3X divided by 3. X is 24. Keep in mind, Elise was 24. X is our age now. We wanted to find out how old she was now, so guess what? Elise is 24 today. That's how old she is. 24 is your final answer in this case. All right, let's keep going here. Number 14. All right. Dylan spent $17 at Elevation Burger for food and $17, I should say, at Elevation Burger for food for him and his friends. Dylan paid $5 for French fries. Okay. Burgers cost $3 each, and Dylan had buy 2 burgers, get 1 free coupons. I should have said coupons instead of, it should be coupons. How many burgers did Dylan get? Well, let's see. First of all, I want to talk about, there's a couple of things here. Let's take the coupon out of the equation for a minute. So let's just ignore the coupon for a minute. Let's say he had no coupons, okay? Let's talk about what he's got to pay for. I'm going to make a little line diagram. Well, he paid $5 for French fries, okay? And then burgers cost $3 a piece. So if he buys only 1 burger, he's going to pay $3. If he buys 2 burgers, he's going to pay $6, which is 3 times 2. If he buys 10 burgers, he's going to pay 3 times 10. If he buys X burgers, he's going to pay 3 times X. So I'm going to let X be the number of burgers he bought. Dylan bought, I should say. Let's be specific. Now, he spent $17 total, so he's got his 5 for fries, his 3X for the burgers, equals 17. And here we go. Subtract 5. I got 3X is 12. 12 divided by 3 is 4. Now, this would be true. X, the number of burgers he bought would be 4 if he didn't have his coupon. So let's see what his coupon's all about. It's a buy 2 burgers, get 1 free coupon. Well, he bought 4 burgers. So let's see. And he's got 2 of those coupons. So he bought 4 burgers. For every 2 he buys, he gets 1 free. So let's see. 4 is 2 and 2. Does that make sense? Hopefully it does. 4 is 2 and 2. Each coupon, he gets an additional burger. He gets an additional burger. So now he's got 3 burgers and 3 burgers. Altogether, 6 burgers. He's going to get 2 burgers for free. So Dylan is going to get 6 burgers. He bought 4. He got 2 free, though. So he gets 6 burgers. Okay? Final answer. All right, a few more of these. Number 15. Zach spends 20 minutes studying per day, plus he does 15 minutes of homework for each class he has homework in. Gene spends 30 minutes studying per day, plus 10 minutes of homework for each class he has homework in. If Zach and Gene spend the same amount of time tonight on studying and homework, in how many classes do they have homework? So let's see. He spends 20 minutes studying per day, plus he spends 15 minutes of homework for each class. And then Gene spends different types of time, but it's for each class. If Zach and Gene spend the same amount of time on studying and homework, in how many classes do they have homework? It looks like they really want us to figure out how many classes they have homework. So I want to make that X. Number of classes each boy has homework in. That's my X. Now let's see. Let's try to write out what Zach does. So let's see. I have Zach here. Okay? Zach spends 20 minutes per day, plus he spends 15 minutes for each class he has homework in. So if he only had one class, he'd be spending 15 minutes. If he had two classes, he would spend 15 times 2 minutes. If he had 3 classes, he would spend 15 times 3 minutes. Well, we have X classes, so he's going to spend 15 times X minutes. Then there's Gene, similar situation. He's got 30 minutes of studying per day, plus 10 minutes for each class. 10x. Now, we want them to spend the same amount of time. Time wants to be the same. So Zach's time wants to be the same as or equal to Gene's time. Now we have an equation. All right, so we'll subtract. There's a lot of ways to solve this. We'll subtract 20 from each side. I get 15x equals 10 plus 10x. Subtract 10x from both sides. I get 5x equals 10. Divide by 5, x equals 2. So they have 2 classes that assign homework if they have the same amount of time to study that night. All right, 3 more questions. This one's a tricky one, so pay attention to this. PJ paid $44.25 in a taxi fare from his house to the airport. The cab charged $2.25 for the first mile, so now I'm driving. I got to pay $2.25 for that first mile, plus $3.50 for each mile. So let's think for a minute. If he goes 1 mile, that's going to be $3.50 extra. If he goes 2 miles, it's going to be $3.50 times 2. If he goes 3 miles, it's going to be $3.50 times 3. So if he goes X miles extra, it's going to be $3.50 times X. Okay, there it is. Now X is going to be the number of miles extra, if you want to call it that. It's going to be the number of additional miles. We have to keep that in mind at the end. So now I have my $2.25 initial fare. This is how cabs work, by the way. If you hop into a cab, you have to pay an initial fee at the beginning, plus $3.50 for each mile, and that totaled $44.25. And there's my equation. And now we can solve it. So I'll subtract 225, and I'll get 350x equals 42. Divide by 350, divide by 350, and x is going to be 12. Now, this is where it gets tricky, and everybody messes this up. It says, how many miles was it from the hotel to the airport? X is the extra miles, because he already went the first mile with the 225. That was the first mile. And so x is now 12 more miles. So to figure out the final answer, I got to take my 1 mile I traveled plus the 12 additional to get a total of 13 miles. That's tricky. All right, number 17. Let's see what we got here. Twice the difference of a number and 5 is equal to 14 less than 6 times the number. Find the number. I want to find my equal sign. Twice the difference of a number and 5 is equal to. So I want to go twice, which is 2 times something, the difference of a number and 5. Twice the difference of something. The difference of a number and 5 is, well, actually, I want to watch this. Twice the difference of a number and 5. So the difference of a number and 5 is equal to 14 less than 6 times the number. There's my translation. So I want to call the x the number. So twice the difference of something. There's a lot of things in there. The difference of the number and 5 is this, x minus 5. I want twice that whole thing. I want twice the difference. I need to figure out the difference first, surrounded by parentheses, times 2, equals 6x minus 14. All right, keep going. We'll distribute. We'll get 2x minus 10 equals 6x minus 14. Subtract 2x on both sides. We get negative 10 equals 4x minus 14. Add 14 to both sides. I get 4 equals 4x divided by 4. X is 1. So the number is hopefully just 1. That's my final answer. Okay, keep going here. One more. 18. Morgan Cell Phone Company charges her $15 per month and 10 cents for each text she sends. Danielle's cell phone company charges her $20 per month and 5 cents for each text she sends. How many texts would Morgan and Danielle each send in order for them to pay the same for their cell phones? So I want to let X be the number of texts that makes them equal that Morgan and Danielle send. Now I have Morgan. I have Danielle. Here we are. Morgan, she's got to pay $15 a month plus 10 cents for every text. I don't know how many texts there are. That's why I'm going to do that. 15 plus 10 cents times each text. Danielle, $20 per month. She's got to pay a little more per month, but she only gets to pay 5 cents per each text. And I want how many texts would Morgan and Danielle each send in order for them to pay the same? I want them to pay the same. I want them to pay equal amounts. There's my equation. All right, here we go. So subtract 15 from both sides. 0.10x equals 5 plus 0.05x. Subtract 0.05x from both sides. And we'll have 0.05x equals 5 divided by 0.05 divided by 0.05. You have a calculator. I'm just going to show you. If I want to divide by a decimal, I'll move the decimal places twice over. So I'll get, this is the same thing as 500 divided by 5. You have a calculator, so don't worry about this if you can't do this. 500 divided by 5 is 100. So they can send 100 texts, and their bills will be the same. Okay, just to reiterate, extra help. Ms. Harkins is available in the morning. I'm available during 9th period. I'm available during activity period. I'm available after school. Mrs. Krager is available period 3. Ms. Simmons is available period 5. Mr. McCarville is available period 7. I know a lot of you have lunch that period. Ms. Zala is available period 8. That's so much time for you to get help. All right. Hopefully you've learned something from this video.